Hello, welcome back. The title of this lesson is called Multiplying Fractions and Mixed Numbers with Cross-cancellation, Part 1. Sounds complicated, but I promise by the end of this lesson you'll understand exactly how to do it. It is actually very crucial. See, we've already multiplied fractions in the past. We're going to be doing that again here. But usually when you multiply fractions, and later on when we divide fractions, you want to simplify the answer after you get the answer and put it in lowest terms. Now that works great, and we can always do that. But this idea of what we call cross-cancellation is what we're going to learn here. We're going to learn how to kind of pre-simplify our fractions so that the answer we get is already simplified. It's going to be much easier to explain by an actual example. And also just keep in mind that this skill is critical to moving on into algebra and beyond. So, and you'll see why as we get there. I don't want to bog it down too early with too much information, but it's extremely important to be able to master this to move on here. It's very simple, actually. Let's take the fraction 4/5 and let's multiply it by 1/2. Now, before we go any farther, for this very first problem, I do want to take a second to visually show you what we're doing here. We multiply fractions. There's 1/5, 2/5, 3/5. This would be 4/5. Remember that 5/5 would be the whole thing. 5/5 is one whole, but this is not a whole. This is only 4/5. So the 4/5 is this much or of a pizza or a pie or whatever you're talking about here. That's what we start with. And then here what we're doing is we're multiplying this fraction by another fraction, which is 1/2. So what we're doing is we're using the second fraction to kind of chop down the first fraction by whatever the second fraction tells us. So 1/2 here is telling us that if we take these, the amount that we start with and cut it into two equal pieces and only keep one of them, that is what 1/2 is. So that's what we're doing. We're taking and cutting this down in half and keeping it. So if we cut what we have into two equal pieces here and only keep one of them, then this is what we have, 1/5, 2/5. So 2/5 is the actual answer. Now let's go through I guess let me go ahead and put the answer over here in terms of our fraction. 2/5 is our actual fraction here. Let me go ahead and calculate the answer, and let's see how we get to our answer mathematically. And also we're going to come up really focus on this idea of pre-simplifying or cross-canceling our fractions. So what we do when we multiply fractions is we multiply the numerator. 4 times 1 is 4, and 5 times 2 is 10. So you say, this is the answer, but this looks nothing like this. Well, you see, this fraction is not fully simplified. Let's simplify our answer, because as you know, we can divide fractions by anything we want as long as we do it to the top and the bottom. So we're going to divide by 2, because they're both even numbers. And then what we actually get is 4 divided by 2 is 2, and 10 divided by 2 is 5. So when we take the fraction 4/5 and we multiply it by 1/2, the simplified version of what we get is 2/5. That's exactly what we got here. Because we originally started with 4/5. When we multiply by 1/2, what it's telling us to do is take what we have started with, cut it into two equal pieces, that's what this fraction is, and keep one of those pieces. And if we cut it into two and keep this amount is 2/5, and that's what it is. So the first part of this lesson is to remember, recall, maybe learn, if you never learned it the first time, what fraction multiplication is. It is taking what you start with and chopping it down by the fraction of what the second fraction is indicating. We cut it in half, that means we slice it right down the middle and keep half of it. If we multiply by 3/4, we keep 3/4 of what we started with. If we multiply by 6/8, that means we just take 6/8 of whatever it is we started with. Now notice when we actually did the multiplication, we had to simplify the answer to 2/5. Now the driving point of this lesson is I want to show you how to make this process cleaner. Let's look at 4/5. And we're going to multiply by 1/2 again. We already know what the answer is. The answer is 2/5. We multiplied the numerators and got a 4. We multiplied the denominators, got a 10, and then we simplified the result. All right? But notice that if we multiply 4 times 1 and get a 4, and 5 times 2 and get a 10, the number 4 and the number 1 is wrapped up into the answer, and the number 5 and 2, being 5 times 2 is 10, is wrapped up into the answer here as well. So because those numbers are in our answer, we can divide by 2 and simplify the final fraction into its final form. But what we can do alternatively is look back at our original problem statement. I think what I'm going to do is rewrite this just so I don't mark up what we have. 4/5 times a half. What you can do is you can look at any term on the top and any term on the bottom and see if you can pre-simplify ahead of time before multiplying. Here we have a 1, here we have a 5. Can I divide 1 and 5 by something to make it simpler? No. 1/5 is already simplified, so I cannot pre-simplify or cross-cancel these. But when I look at these numbers, the 4 and the 2, they're both even numbers. So I can divide the top and bottom by 2 ahead of time, because when you think about it, all I did in the previous way was divide by 2 but after the multiplication. So here's the deal. When you multiply fractions, you can either multiply first and then simplify by dividing, or you can pre-simplify by dividing first and then execute the multiplication. Here I have a 4 and a 2, and I can divide top and bottom by 2. So you say to yourself, 2 divided by 2 is 1, and then 4 divided by 2, same number, is 2. So literally you strike through with a single slash, and you say to yourself, I'm dividing this by 2, and it gives me this, and I'm dividing this by 2, and it gives me this. Now I have pre-simplified these numbers. Now I have a 2, which replaces the 4, and here I have a 1, which replaces the 2. And then I can multiply what I now have. And so 2 times 1 is 2, and 5 times 1 is 5. And this is the final answer, and it matches what we had before. Now you might say, why would I ever do that? Why would I ever pre-simplify? Well, it's easy when these numbers are small, right? Because these are very easy numbers. But if I give you fractions that are large numbers, you have to multiply them and get a really large numerator, and multiply the bottoms and get a really large denominator, and then you have to simplify the result. It's going to take more work to do that than it is to pre-simplify, or cross-cancel is another way of saying it, ahead of time. So usually when you multiply fractions, and later on when we divide fractions, we're going to pre-simplify them as much as we can before we actually execute the multiplication or the division. And you're just going to have to trust me also at this point that this process carries over into algebra. I'm not going to get too ahead of myself, but when we do algebra where we have letters and numbers, then when we multiply fractions in algebra, we have to pre-simplify. Or I shouldn't say we have to, but it makes it way easier. So this process that you're learning now is not something that you flush and throw away. It's something that you'll be using forever, for years and years and years. All right, so the fraction that we got was 2/5. All right, let's go on and execute problem number 2 and see what that is. Let's take a look at a related problem. Let's again take 4/5, but in this instance, we're going to multiply by 3/4. Right? So how would we do it kind of the old way? We're going to do it 2 ways. Let's do it the old way, where we simplify at the end. 4 times 3, we know. We can write it as 4 times 3 on the top, and then 5 times 4 on the bottom. That's how we multiply fractions. 4 times 3 is 12, and 5 times 4 is 20. Now these are even numbers. We know that we can simplify these. So I write it as 12 on the top and 20 on the bottom. Now what am I going to divide by? I can divide by 2, but if I'm a little more careful, I realize that I can actually divide both of these by 4. And what I get, 12 divided by 4 is 3, and 20 divided by 4 is 5. And the answer is 3/5. All right? Now, how do we do it where we pre-simplify ahead of time? Let's rewrite our problem, 4/5. And this will be the last time that we do it both ways. All right? I'm going to rewrite it again because I don't really like marking up my original problem statement. And I'm going to ask myself, of the 3 and the 5, can I pre-simplify these? Can I divide top and bottom, this 3 and this 5, by some number to make it simpler? No, I can't, because 3 and 5 are not divisible by some common number. But when I look at these two, 4 and 4, of course I can divide both by 2 if I want to, but I can more easily divide both of them by 4. You want to divide, just like when you're simplifying numbers by fractions, you want to divide, when you pre-simplify, by the largest thing you can to make it easier. So what you say to yourself is, put a single strike, 4 divided by 4 is 1, and 4 divided by 4 is 1. You just pick something common to divide. I divide both of them by 4. 4 divided by 4 is 1. 4 divided by 4 is 1. You have to divide by the same number, just like when you simplify fractions. Now, the 1 replaces this, and the 1 replaces this, so 1 times 3 is 3, and 5 times 1 is 5, and you're done. And you get exactly the same answer. You're just going to have to trust me. Very soon here, we're going to get some larger numbers that make it a very, very easy to do the pre-simplifying, the cross-canceling, rather than simplifying at the end. Now, before we go on, I want to take this opportunity just to show you, this will be the last time I show you with the magnets here, what this looks like. Here's 1/5, 2/5, 3/5, and 4/5, right? And we're multiplying by the fraction 3/4. And that's 1/5, 2/5, 1/4, 2/4, here's 3/4, right? So what this is really saying, in effect, is we start with this amount of pizza and we chop it down by whatever the fraction here is telling me to chop it down by. This second fraction behaves like a hatchet or an axe, and you just cut it down. In the previous example, we started with this much pizza and we cut it down by half. So we cut it in half and we keep that. That's what happens when we multiply. But here, we're not multiplying by a half, we're multiplying by more than a half. So we expect that our answer will be bigger than 2/5 because that's what we got when we cut it only in half. But here, I'm telling you to cut it by 3/4. What does 3/4 means? What does it mean? It means that you cut your what you started with into 4 equal pieces and you keep 3 of them, right? Well, if I start with this, 1, 2, 3, 4, cutting it into 4 equal pieces would be exactly fifths, but I'm keeping 3 of them, 1, 2, 3. So you can see the answer is 3/5 because you're keeping 3 of those pieces, and I can kind of grab these. I'll steal them from the other board and put 1/5, 2/5, and then finally 3/5. So what you're doing is you're starting with 4/5, multiplying by 3/4. 3/4 means cut it into 4 pieces and keep 3 of them. Here I've cut it into 4 pieces, I keep 3 of them, and the answer is 3/5. That's what fraction multiplication is doing. It's chopping down what you start with to get where you need to go. All right, now that we have the basic idea underway, we're going to only work on cross-canceling these fractions. So what about 3/5 and 5/9? I'll read it. I'm sorry, 3/4 and not 5/5, 5/9. Sorry about that. 9ths right here. And then multiply by 5/9, like this. So how can we pre-simplify this? The 5 and the 4, I cannot divide them and simplify, but the 3 and the 9, I can. They're both divisible by 3. So I divide both of these quantities by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. You say it to yourself out loud like that. Now, what is left over? 1 times 5 is 5, and 4 times 3 is 12. And you get an answer of 5/12. Notice that when you do it correctly, when you pre-simplify everything correctly, the answer that you get should be completely simplified. You should never have to simplify your answer again because you've pre-simplified. So it's kind of like when you make eggs, right? When you scramble some eggs or whatever, a pot of soup or something, you can season with salt and pepper before you pour the eggs in the pan, right? Like you can whisk your eggs and put the salt and pepper in and then pour it in the pan, or you can pour it in the pan and then salt and pepper your eggs in the pan. You see, it's kind of an analogy, but it's the same kind of thing. You're going to get the same thing if you season before you cook or if you season after you cook. I know it's not exactly perfect, but you're more or less going to get the same thing. If I simplify ahead of time, I'm going to pre-divide everything by common numbers, and I'm going to get the fully simplified form. Or if I just multiply and then notice I'm dividing by the same thing that I divided by here, I'm going to get the same answer. So like seasoning before and after cooking, you get the same result. All right, let's take a look at 7/8 multiplied by 2/3. I'm going to write it again, 7/8 times 2/3. All right, now I have a 7 and a 3. Can't do anything with that. Those aren't divisible by something common, but these are both even. I'll divide by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. And now with those numbers replaced, 7 times 1 is 7, and 4 times 3 is 12. And the answer we get is 7/12. You see, I have to do a lot of talking in the beginning of a lesson, but you see how easy it is now that we have that talking out of the way to get the answers quickly. What about 5/8 times 7/10? I'm going to rewrite it, 5/8 times 7/10. Now I know that the 5 and the 10 can be simplified. I'll divide by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. These are not able to be simplified. So I'm done with the pre-cancellation. 1 times 7 is then 7, and 8 times 2 is 16. And the answer you get is 7/16. Now, I want to caution you for a second, or I shouldn't say caution, but just take a look at this. If we did it the other way, it would be 7 times 5 is 35, and 8 times 10 is 80. So you would have 35 on the top and 80 on the bottom. You can already see how the numbers in the answer are getting very big, and you have to do a good bit of simplifying and long division to help you simplify those answers. But doing it ahead of time was very simple to do in our head. That's kind of another reason we do it this way. All right, let's take a look at 1/12, and we'll multiply it by 4/5. I'll rewrite it. 1/12 multiplied by 4/5. All right. Can I simplify 1 and 5? Nope, can't do that. But 4 and 12, yes, I can divide by 2 if I want, but I can also divide by 4. They're both divisible by 4. Now here, I'm intentionally going to not divide by the best number possible. Let me show you what happens. We know we can divide by 4 here because they're both divisible by 4, but let's say you don't realize that. You say, well, they're both even, I'm going to divide by 2. 4 divided by 2 is 2, and 12 divided by 2 is 6. And you say you're done. Well, if you're done, then you'll get 1 times 2 is 2, and 6 times 5 is 30. You'll have 2 over 30, and you'll be able to simplify that answer. The reason that you would still be able to simplify the answer is because you did not fully pre-simplify ahead of time. Notice that we can look at the 2 and the 6. We can keep simplifying by dividing by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. I'll just kind of write it down there. And now that we have everything simplified, we can't do anything further. Then we have 1 times 1 is 1. That's what's left. And this is the only thing left. 3 times 5 is 15. 1/15. So you see, you get the same answer, the correct answer, no matter really what you do. If you don't pre-simplify, you're going to get 4 on the top and 60 on the bottom. I promise you, if you simplify 4/60ths, you're going to get 1/15. If you only divide by 2, then you would have the 2 and the 6. You would have 2 on the top and 30 on the bottom. If you simplify that, you still get to the same place. If you continue simplifying your numbers, then you, of course, get the correct answer. And so the point is that the best thing to do when we had the 4 and the 12 here is just to divide top and bottom by 4. Then you pre-simplify it in the least number of steps. So just like when simplifying fractions, you want to divide by the largest number that can divide into top and bottom. When you pre-simplify, you really want to do the same thing. But if you forget, just keep simplifying over and over until you're basically done. That's really what I wanted to show you there. From now on, we will try to do the best simplifying we can. What about 2/3 multiplied by 9/10? Now here is a situation we haven't had before because we have the 3 and the 9, and we see that we can divide both by 3. So 3 divided by 3 is 1, and 9 divided by 3 is 3. But we also see that we can divide the 2 and the 10 by a common number. We can divide both of these by 2. So we divide both of these by 2. 2 divided by 2 is 1, and 10 divided by 2 is 5. So we try to cross-simplify. That's why it's called cross-cancellation. It's kind of making a little X. You try to simplify the cross members, one in the top and one in the bottom, and you try to simplify both pairs. And in this case, what we're left with is 1 times 3 is 3, and 1 times 5 is 5. And the answer is 3/5. Now let's look at our original problem. It would be 2 times 9 is 18, and 3 times 10 is 30. Certainly you could do that, but you would have more steps to simplify the final answer. All right, let's take a look. I think we only have 2 more problems. And this will, I think, more readily show the power of this method. Let's take a look at the fraction 1 and 2/3, and we'll multiply that by the mixed number 1 and 2/5. What we want to do as step number 1 is we want to turn these into improper. So 3 times 1 is 3, and then we have 5/3, and then 5 times 1 is 5, plus 2 is 7/5. Now these are the ones we're going to multiply. It's equivalent to what we have here. So let me rewrite them. So we have 5/3 times 7/5. All right, so we see we have a 5 and a 5. You can just strike through and cancel them, but really you're really saying 5 divided by 5 is 1, 5 divided by 5 is 1. And the 7 and the 3, they don't really do anything. You can't simplify that. So then we multiply. 1 times 7 is 7, and 3 times 1 is 3. Now you can leave it at 7/3, or it's better to go ahead and just turn it back into a mixed number. 3 can go into 7 2 times because 2 times 3 is 6. The remainder, 7 minus 6 is 1, and it's out of 3. So it's 2 1/3. Or you could write it as 7/3 if you want. 2 1/3 is probably the best answer. All right, last problem. 2 2/3 multiplied by 2 1/4. Again, change it into a improper. 2 times 3 is 6, and we have 8/3. And then 2 times 4 is 8, 9/4. 4th coming from here, 3 coming from there. Now let me rewrite this. We have 8/3 times 9/4. All right, so we have 3 and a 9. That can both be divided by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. And then we turn our head the other direction and look at 8 and 4. We'll divide both by 2. 4 divided by 2 is 2, and 8 divided by 2 is 4. Look, I did exactly what I told you not to do. Of course, we divided both by 2. That's fine. But I'm not going to erase this because actually 8 and 4, you could have just divided by 4 and saved yourself the step. But I was on autopilot and I was not thinking correctly, so I divided by 2. But that's okay. We see the 4 and the 2. We can divide them by 2 again. 2 divided by 2 is 1. 4 divided by 2 is 2. And we get to exactly the same place. 2 times 3 is 6, and 1 times 1 is 1. And 6 divided by 1 is just 6. So the answer is just 6 there. So in this lesson, we have reviewed the idea of multiplying fractions. What does it mean to multiply a fraction times another fraction? We've reviewed kind of the old way we used to do it, just multiply the numerators, multiply the denominators, simplify the result. But we've also brought up the concept of cross-canceling. Very, very important for you to understand that you can pre-simplify. As long as you're multiplying those fractions, you can pre-simplify and then do the multiplication. It gets you the same answer as multiplying first and then simplifying. Just like when you're cooking, you can put salt and pepper in as you're cooking or before you're cooking, or you can put the salt and pepper after you're cooking. Either way, the salt is going to be in there. So if you pre-simplify or you post-simplify, either way, you get the same correct answer. And I will say that when you get into algebra and letters are running around with your numbers, this idea of simplifying ahead of time, it's going to be completely indispensable. We have to learn it. So practice all of these yourself. Follow me on to part 2. We'll get more practice with multiplying fractions with cross-cancellation.